So today we're diving into something called HydrAI SWE. It's a really powerful AI platform that's totally changing how we predict and manage our most vital resource, water. Let's get into how it all works.
All right, let's start with a big question. Think about it. Every single winter, just massive amounts of water get stored as snow, frozen solid across mountains and landscapes. So how on earth do you know how much water is actually in that snow? And maybe more importantly, when is it all going to melt? That's the huge challenge water managers grapple with every year.
Well, the answer, as you might have guessed, is artificial intelligence. HydrAI SWE is a fully operational AI system that's built for this exact problem. It pulls together satellite images, weather data, and on-the-ground observations, and then uses some pretty advanced deep learning to paint a really clear picture of our water future.
So, who is this for exactly? Well, it's actually designed for three totally different groups. For hydrologists, it's this super powerful analysis tool. For emergency managers, it's a life-saving early warning system. And for farmers, it's like a guide for making smarter calls on crops and irrigation. It's pretty cool. One system solving a really complex problem from multiple angles.
Okay, so its first key job is predicting something called SWE, which stands for Snow Water Equivalent. The easiest way to think about it is this. SWE is the amount of water you'd get if you could just snap your fingers and instantly melt an entire snowpack. It's the number that tells us exactly how much water is just sitting there, waiting to flow into our rivers and reservoirs.
And here's where the real magic comes in. The system doesn't just tell you the SWE for today. No, it actually generates forecasts for 7, 14, and even 30 days out. This gives water managers a critical heads up, a window to plan for potential floods or even droughts. It lets them be proactive instead of just reacting to a crisis.
And that predictive power leads right into the platform's second huge function. Because, once you can predict the water, you can predict the risk. All that SWE data becomes the foundation for a flood warning system that's designed to protect entire communities.
What the system does so well is turn all that complex data into simple, actionable alerts. It uses machine learning models that have been trained on past flood events to classify the risk right now into three really clear levels: high, moderate, or low. This just cuts through the noise and lets emergency managers get the word out fast.
But it's not just about public safety, as huge as that is. This same hydrological intelligence has massive implications for agriculture and our food supply. Knowing how much water is going to be available and when is absolutely crucial for farmers.
This is where it gets incredible for farmers. The platform gives them tools to forecast soil moisture by combining weather data with satellite observations, including data from NASA's SMAP mission, which is literally designed to measure moisture in the top layer of soil all across the globe. This allows for really precise crop recommendations and even helps forecast yields. This is what data-driven farming really looks like.
Okay, let's pause for a second. We're talking about this really powerful AI making critical predictions that affect lives and livelihoods. And that brings up a hugely important question we have to ask of any AI system. Can we actually trust the numbers it's spitting out? How do we know it's not just making stuff up? And the answer from the people who built HydrAI SWE is this powerful commitment they call the zero fabrication policy. The whole system is built on a foundation of absolute data integrity. It's a promise that it will never, ever invent data just to fill in a blank.
And this policy isn't just a slogan. It's backed by 5 super strict rules. For example, it will never fill gaps in the historical record with simulated data because a bad guess about the past could lead to a dangerous mistake about the future. And if the data just isn't there for some reason, it simply displays NA. It won't guess. That kind of transparency is everything when you're building trust.
And the results of this whole approach? Well, they really speak for themselves. The system's core model has what's called an R-squared score of over 0.88. So what does that actually mean? It means the model can explain over 88% of the variation in the real-world data it was tested on. That is some excellent, really reliable predictive power. And look, a score that high doesn't just happen by magic. It's built on a rock-solid data foundation. The model is trained on a data set with 95% overall quality, stretching back an incredible 54 years, with real records from 8 active monitoring stations. Quality data in means quality results out. Simple as that.
So how does this all fit together? Let's take a quick, simplified peek under the hood at the journey data takes from the outside world to your screen.
Think of it like a 6-step journey.
First up, acquisition. The system is constantly pulling data from all these weather and satellite sources. Then, storage. That raw data gets saved to a central database. When you need a forecast, an API smartly retrieves just the relevant pieces. Now here's the fun part: processing. Powerful PyTorch models analyze the data and make their predictions. The results are then delivered as an optimized response. And finally, visualized on a dashboard as these easy-to-read interactive charts. It's a seamless pipeline from raw data to real insight.
And that really brings us to the big picture here. A system like this is a great reminder that this technology isn't just about numbers and code. It's about using our most advanced tools to solve very real, very human problems. It's about creating safer communities, ensuring we have a stable food supply, and building a more sustainable future for all of us.
And that leaves us with one final big question to chew on. We've just seen how a really focused AI can help us understand and manage something as powerful and complex as our planet's water cycle. It really makes you wonder, if AI can help us master water, what's the next huge global challenge it can help us solve?